let's continue with the z-distribution. And now we're going to talk about going from probability to scores, and we're going to finally figure out if the crazy cat lady is indeed crazy. Last lecture, we learned that there's a cycle where we can start with a score and standardize it to a z, and then use our model to get the probability. There's an opposite cycle as well. So talking about a probability, we can convert that to a z, and then we can use this kind of rewritten formula to turn it into an x. So you see what we do once we have the z is we multiply our standard deviation, and that could be positive or negative then, depending on whether the z was to the left or the right of the mean. We add it to the mean, and that gives us the x value, which will either be less than the mean or greater than the mean. This is honestly doable in the table, but it's a lot easier to do in R. So in R, the formula is Q norm, and then you put in the percentage. Okay, so Q norm and the percentage. Okay, so remember the 90th percentile? We were talking about those when we were doing box and whiskers plots before, and we were talking about percentiles. So our Q norm for that would be Q norm 0.90. And put it in decimal form. Don't put 90 or don't put 90%. It'll get confused. So we have to remember probabilities in decimal form now. But what about 95% of the probability in the middle? Okay, remember when we looked at the empirical rule before, we said that about 95% between plus or minus 2 standard deviations, or plus or minus 2 standard deviations holds about 95%. But we want to be more exact now than that. So what we're after here is saying, okay, 95% is in the middle. So this middle area, okay. And so to do the middle part, we need to ask what is left over. So if we want 0.95 in the middle, that means 1 minus 0.95 or 0.05 is on the ends, okay? But we've got two ends, so 0.05 divided by 2 is 0.025. And so basically 2.5% is in each end, all right? So, and I'm just going to kind of draw that somewhere close to 2, although we know it's not exactly 2. All right, so this area here is 0.025, and this area down here, it's very dark shading, is also 0.025, okay? And now we can do Q norm 0.025. And what we get is a z-score that is equal to minus 1.96. And that is a magic number. On the right-hand side over here, it's a positive 1.96. Okay, so plus and minus 1.96 is a magic number that defines 95% in the middle and 5% out on the tails. And we'll use that so much that you'll basically have that about memorized. Now, what about this percentile, right? Because that's basically everything up to that point. So that's going to give us something like a z of 1.28. And so round in here. And that one means everything from there down is 90%. And 1.28, which means there's 10% up here in the upper tail. So remember we had a mean of 3.5 and a sigma of 1.25. So we expect 90% of all results to be less than or equal to what number? So remember, we can do z times sigma plus mu equals our x. So if we have 1.28 times 1.25, and then we add 3.5, we get this 5.1. Okay, and we expect 95% of the results to fall between what and what. Okay, so now we have to do two calculations here. So we have negative 1.96 times 1.25 plus 3.5, and then we have positive 1.96 times 1.25 plus 3.5. So on the low end, we have 1.05, and on the high end, we have 5.95. All right, so we expect 95% of the results to fall between 1.05 and 5.95. By the way, if you add those two numbers, 1.05 plus 5.95, and divide by 2, you get the mean, okay? And so that's a useful thing because, of course, this curve is symmetric, so the mean has to be in the middle. So, okay, what about the crazy cat lady? She has 6 cats. Suppose, and yeah, I did go research this a little bit, that the average number of cats in a cat-owning household is 2, with a standard deviation of 1. So 95% of the time, we expect people to have how many cats? And so here we go with our 95% interval from negative 1.96 to positive 1.96. The mean is 2, sigma is 1. So on the low end here, right, we've got negative 1.96 times 1 plus 2 equals negative 1.96 plus 2, which is equal to like 0.04. On the high end, we have 1.96 times 1 plus 2 equals 1.96 plus 2, or 3.96. So notice that nobody's going to have 0.04 cats or 3.96 cats, right? In statistics, you get these numbers that aren't actually representative of the real things sometimes, but we would basically say, yeah, we expect 95% of the time for them to have between 0.04 and 3.96. So is 6 unusual? Yes, because this point here corresponds to 3.96 cats, and she's way out here with 6. Okay. We can also look up the 99th percentile. So the easiest way to do this would be to put in Q norm 0.99. And that gives you a z of about 2.33. Okay, so it's going to be somewhere here. In x terms, then, x is equal to z times sigma plus mu. So now our z is 2.33 times sigma is still 1, plus our mu is 2. So that equals 4.33. Okay, so in x terms, 4.33. So does the crazy cat lady have more cats than 99% of people who have cats? Yeah, still over here somewhere with 6. Okay, and we could of course put 6 into the formula. We could say, z is equal to 6 minus 2 over 1. which would be 4.0, and then we could do p-norm 4.0 to figure out what the probability is. I'm going to leave that to you to go check out.